Okay, good morning. Welcome to
FamilyMath127.
Ooh, you okay?
Yep.
Family Math 127. Okay, so we had a friend of mine told me about a book she saw in a bookstore this past weekend. It was called The Math Book by Clifford Pickover.
Yep.
So I bought it, and it was pretty cool, right?
Yeah.
We were just flipping through it. So I opened it up this morning, just to a random page, and decided we'd just talk about it. So the page I happened to open up to was right in the middle of the book here, and it talked about something called the Prince Rupert problem. And I have to tell you, I had never heard of this problem before. It's pretty neat. So the Prince Rupert problem is about cubes, but we're going to start with an easier problem about squares.
Yep.
Okay? So if I draw a square, and you guys have your zone tool squares, right?
Yep.
The question is, what is the largest square that I could make that could fit through this square?
Well, the same size square can fit through it.
Okay, can you show me? That's a great observation that you made. How do you know that the same size square can fit through a square?
Well, you just tilt the square like this, and then you can slide it through.
Okay, very good. Do you see that? That's a great. Here, let your brother actually do it. How do you get that one square through the other one? Okay, it fits right through if you tilt it sideways. So with that observation, do you think you could draw how long is the side of the longest square that could fit through a given square?
Well, it's equal to the sides of the given square.
Well, okay, so we just showed that a square that has two squares that are the same size actually can go right through each other already. So the largest one must be a little bit larger.
Yeah.
Okay?
But how large?
How much larger? So what do you think, based on the observation that you made, which is a great observation, that two squares of the same size can fit through each other? What do you think is the largest square that can pass through another square?
Well, maybe.
Or how long the side is, I mean.
Well, if we just say the square is.
You have size 1.
Yeah.
It has to be bigger than 1.
It has to be bigger than 1. Yeah, because we know this works.
It looks like there's a little space left over.
It does look like there's a little space left over.
But how much is that little space?
How much is it? So maybe you can draw. Don't calculate it. See if you can draw it. What would be the largest side length that can fit through this square or the square you drew?
It would be the square that just touches the edges.
Aha.
Yeah.
Like
Do you see that?
Yeah.
And so I snuck over here. Oops, sorry, I put your squares down. Can you lift your square up? Okay. So a square that had a side length of the diagonal would be able to go through it, right?
Mm-hmm.
Pretty cool, right?
Yeah.
Yep.
So here's that square
So.
made out of zone tool compared to the square. See how big that is?
Yeah.
Isn't that amazing?
Wow.
This square could go right through this one if the zone tool balls weren't in the way.
Yeah.
That's pretty amazing, right?
Wow.
Okay, so now I'm going to put the camera on pause and we're going to talk about the same problem real quick for a cube.